Optical LAN. Okay, I see the recording has started. So the webinar today is on Optical LAN Global Markets Report. My name is Stefan Heldens. I'm with Nokia, and I'll be moderating this session today. Obviously, in the different parts of this webinar, people, and there will be different presenters, and there will be more time for introductions at that time. Today, there are two big sessions large sessions on this webinar, and mainly on the report itself. And Martin Chiesa will give you an introduction on those. And then we thought it would be a good idea that we show you references to illustrate kind of the growth that we see in optical LAN markets over the last years. A bit of housekeeping before we start. You will be muted, so if you have any questions during the session, feel free to use the chat options in this webinar to communicate your questions, and we will take those questions at the end of the session. So that you can that we in favor of time, that we don't waste, or that we don't spend too much time on questions, so we take them at the end. Obviously, this is recorded. The session will be made available also on our YouTube channel, and the slide decks will be distributed. So then, with no further ado, I will give it the floor to Martin, who will give us a view on the actual report. This report is obviously also available for the interested people.
Thank you, Stefan. Good morning or good afternoon, everybody, wherever you are, and thank you for joining us today. As Stefan mentioned, I'm going to share with you some of the findings of our latest report on Optical Local Area Networks, OLAN. I'll start very quickly giving you a few lines about BSRIA, which is the company I work for. BSRIA stands for Building Services Research and Information Association. It's a member-based non-profit association founded in the UK in 1955. We are specialized in building services and the construction industry. For some of you might not be familiar with the term building services, I like to think of it as all the systems and subsystems that make a building usable and workable. So except the building fabric itself, all the rest. And BSRIA provides research, consultancy, test, and it's both technical research and market research. And it has presence in France, China, UK, of course, and the USA. So the area I work for is market research, and it's World Market Intelligence, WMI. And what we produce there is annual reports on several markets on all these building services that I mentioned, and about 90 countries are covered in total. We also run data collection clubs, whereby typically we have an association with a number of members that share the confidential information with us. We aggregate that information and send it back to the association, so they get reliable and frequent data, and at the same time confidentiality is kept. And then, of course, we also run bespoke and market research consultancy, bespoke research and consultancy. So the first time BSRIA did a research on optical local area networks was back in 2011. And since then, the market has been growing as seen in the chart. In 2015, just a few years back from now, the market was really small, was below $100 million. And then we can see how that market evolved quite quickly up until 2019, where we in 2020 anticipated a market contraction of about 10%. That didn't take place. It was just a mild 2-3% contraction. And what's remarkable is what we saw afterwards. which is the market more than doubling in only a few years, from 2019 to 2023. And these unprecedented growth has several explanations. One of them, of course, is the increasing awareness about the existence of optical networks. Then also the fact related to the previous that more vertical markets are embracing the technology and adopting the technology. There's the effect of the delayed projects during the pandemic that also were started at a later stage. But what was surprising was the outstanding growth that we saw in China, the very big growth that we saw in America, so North America and Latin America, and also rising sales in Europe, which is a late adopter of the technology. Inflation had probably a double effect. On the one hand, of course, increasing the value of the optical local area network solutions sold, but at the same time, probably making companies and investors look for alternatives to conventional Ethernet networks, as passive optical networks or optical local area networks are much more economic than their sort of, so to speak, counterpart in Ethernet. And then, of course, there's increasing pressure on green concerns, on environmental concerns, and from all sort of stakeholders, from governments, from companies, from the public. And companies are setting their ESG policies, and this, as we will see in a minute, has optical local area networks have a lot to add to this. So what I'm going to show you now is how the main verticals for the global market, this is global market, main verticals of OLAN, of optical local area networks, looked like in 2019. And as we can see, three verticals accounted for 80% of the market. So office buildings was number one, hotels and government number two. There was also an important one was senior and student accommodation. But if we look at offices being so important, and we think, as we probably know, how much offices were impacted during the pandemic and in the aftermath of the pandemic, so still nowadays, it is remarkable to think that optical networks managed to grow despite of this situation. And in fact, now I'm showing you here how the market looked like in 2022, with education taking the lead, but also hotels are also important, but of course, because of the number of other verticals taking a share of the total market, they look smaller, but they are really important. Hospitals, mixed use, industrial premises, logistics, very important growth there, stadiums as well, and large venues. There are a number of vertical markets adopting this new solution, newish, and we think it will continue to be this way for the foreseeable future. So, actually, I am realizing, if you excuse me, I'll go back, because I think for some reason the presentation didn't show. This is what I wanted to show. Perhaps it was me missing it, but we expect the market to be between 1 billion and 800 million in the future. So we expect quite a healthy growth of optical local area networks over the next few years. So which are the drivers for this growth, this future growth? Well, pretty much the same that we had before. So I'm not going to repeat a lot of them, but speaking about mounting environmental pressure, back pressure on environmental matters, I'd like to point out a few things, but with the use of optical local area networks, you have much lower capital expenditure and much lower operational expenditure. And that also translates into obviously a more greener network. So you're required to use less power and less cooling, both in terms of the installation, but also the consumption, less switching. Cabling infrastructure is a fraction of what you would normally use in an Ethernet conventional network. You require probably, you can have savings of up to 90% of space, but anywhere between 80 and 90%, comparing one infrastructure with the one architecture with the other. Installations are much simpler. They're future-proof because they're deploying a single mode fiber whose bandwidth is still yet unknown. So in the future, you only need to replace the electronics. All the passive components will remain the same, and you don't even need to replace the entire electronics. It can be done at a staged phase. So lower maintenance, centralized management of the network from a centralized point, distances up to at least 40 kilometers from that centralized point, much lower consumption, as I said before, and in essence, lower cost of ownership, a much lower cost of ownership compared to conventional Ethernet networks. So if you have, as I said before, lower CapEx and OpEx, you end up having a much smaller environmental footprint on your network and your company. And that is all from me. Back to you, Stefan. Thank you.
Thank you, Martin. So that brings us to the second part of this webinar. And here we will show you some references to illustrate actually the growth that Martin was talking about. You could see in the curve that from 2022, we have seen an acceleration in the demand for optical LAN networks. Now here you will see a number of vendors that can give you some use cases as a testimonial. So I'll start with Nokia myself. So I run business management for FN Enterprise in Nokia. And in that perimeter, also optical LAN falls. Besides that job, I have also a hobby, and that is running for APOLAN. I'm the chairman of the European Committee there. So if people are interested to know what is going on in Europe or what APOLAN's activities are in Europe, I'm also the right person to contact there. In Nokia, we have quite some references, more than 500. I think it's even much more than that. But 99% of our project, of our optical LAN projects, are done through partners. So when I say it's around that, that is just illustrating that, because lots of our partners have a high degree of self-sufficiency, and they will go out and promote our solutions to their customers. And when I say Nokia in this presentation, I mean, of course, Nokia and our local partners that actually implemented these solutions. So I'll show you here 3 reference cases more in detail. Sometimes I'm asked, why is it so difficult to find, or why is it these reference cases, why are they not more openly communicated? Because obviously, yeah, we are in this 3-party situation business where our end customers do not always want to expose the details of their networks. For these references that I share today, they're public, so you can also find some of them back in YouTube, on YouTube movies, and some use case descriptions on our site. So Singapore Changi Airport. So you might know that is a quite large hub in the region. And typically what is appealing to the customer and the partner, obviously, towards optical LAN is that actually the topology of an airport very much corresponds to the topology of an optical LAN network, which is tree-based. You can think about the arms or the terminals inside of an airport corresponding to the topology of an optical LAN network. Again, there we are covering with our solution a large surface, and at particular parts we have the need for a high bandwidth. That combined with the reliability of our solution and the security aspects that we can give to our partners and our customers is very appealing for that particular case. In Changi Airport, the main use case is the CCTV surveillance system. So again, there are lots of high quality video content that needs to be transported and needs to be made available to several parties inside of the airport. We are deploying there 4-port and 6-port ONTs, but I guess that is of lesser importance. If you switch over to the next use case there, that is on healthcare. So there we have Clínicas de las Américas. That's an all other part of the world, being Latin America and Bolivia. So there it's a hospital campus. Again, a large surface where the need for higher bandwidth services is obvious. In medical applications, you're not allowed to compress images because that could influence with the diagnostics inside of a hospital. So there again, there is a need for a high performance and a very secure and reliable solution. And as such, an optical LAN network is appropriate for that. In order to illustrate kind of the project in the next slides, you can see I've included some pictures there on how it was deployed. And at the top right, you can see also that it is used for multiple services. Inside of a hospital, you have the need for Wi-Fi access, for access control, for IPTV in the patient's room, for voice services, and so on and so forth. All that can be controlled and managed in an optical LAN environment in a let's say in a more performant way than you are used to do that in a traditional LAN environment. Yeah, we can skip forward into these slides. Again, there it's always striking to me how clean an optical LAN installation is if you compare that with the large cable trees that we are familiar of in traditional LAN solutions. This looks quite tidy and neat because actually the small fiber holds the equivalent of a large cable bundle. Also, different powering options are available there. We can skip forward. Yeah, again, illustrations that all different types of services are connected. Even it goes up onto the parking lot outside of the campus is also all connected over the optical LAN. Please go forward. The next reference that I wanted to share with you is in Israel. So there we are in EMEA. So we had Asia. We had Latin America. Now here we are in EMEA, in Israel, and there we have provided our optical LAN solution in 2 buildings, and in fact each on 7 floors of these buildings, and we are deploying there in a redundant fashion using our 4 and 8 shelf solutions. And particularly appealing to this customer was the flexibility in deployment. The deployment while the building is set, the network design, because it's a tree structure of an optical LAN, is much simpler. So that is appealing, but also the deployment when the installation is fully done. In that sense that these buildings are used to house startups. And startups, as you might know, they can grow or they can shrink or they can disappear or they can be successful and grow. And as such, network resources need to be flexibly allocated to parts of that building, of that office environment. So there, the flexibility that you have in an optical LAN environment by allocating resources to certain entities is something that was very appealing, on top of the lower TCO that an optical LAN solution brings. Again, this use case you can also find back on YouTube. If you're interested, there is a Nokia channel where some of these public references are displayed. So I think these are 3 Nokia cases, and I would like to hand off now to the next presenter, and I believe that would be Slobodan.
Hi, everybody. So I'm Slobodan Zlatkovic, and I'm Vice President for the Enterprise Sales in DZS. We started our optical LAN journey a while ago. Actually, it's more than a decade ago, with few very interesting projects. So I would like to mention, Formula One circuit with one setup fixed and a couple of setups which are moving from one circuit to another. The other interesting projects for us at these times were Buenos Aires Safe City project with their federal police to monitor the let's say to backhaul security cameras and access points used for the police applications. And what was always, let's say, early adopting vertical for us is hospitality, with several very important hotels in different geographies. So my first project was in Italy, Hotel Gallia in Milano. So very luxury hotel there. Afterwards, actually, we were surprised by the number of verticals in which optical LAN solutions are applicable, and it was quite quickly adopted from our perspective in some of the verticals which we are expected to be much more conservative, like banks or like specific manufacturing facilities, government and military applications. But nowadays, when we talk about verticals, we talk about all. So practically, including corporate ones, business parks, shopping malls, logistics centers. Optical LAN solutions are massively used also as a building management systems for data centers, smart cities, condominiums. They're used in a healthcare for hospitals and assist living. They are used in education, university, schools, student accommodations, but also what we are proud of are and it is shown in one of the slides, are smart stadiums. And like Stefan was mentioning, airports or other, let's say, special venues. So just a few highlights of DZS experience, examples. One of, let's say, first projects, like Stefan, it was also for us a very nice reference in Israel, and that was the Bank of Israel. So very interesting, because you would not expect, in the conservative environment like banks are, to start with this, let's say, innovative infrastructure project. And evolution was quite interesting. Actually, we started in the bank with a building management system. It was well accepted. So then we extended to another network, which is IP telephony network inside of the first building of the Bank of Israel. And that was also working fine for them. And then it was massively adopted practically for all of the LAN services there. Meanwhile, they also build up a new building. So that's the first building. They have a second one. which is also, let's say, using our optical LAN solution. Interesting things are that from the very beginning, necessity for the high availability, and in the case of banks with active solutions and OLTs in the different geographical locations for security reasons were, emerging as a strong requirement. In all of these buildings, we have several thousands of ONTs deployed, and as you can see, some of them are with the form factor, wall plate form factor. Some of them are desktop there. Next example is on the next slide, and this is again a special project which we did. Like Stefan was saying, all of our projects are with partners. So in the case of Atlanta Falcon Stadium, so Mercedes-Benz Arena, it was done with IBM. So that was the first smart stadium in the world. And it was a massive deployment, I would say. So our biggest chassis, several of our biggest chassis are deployed there, together with more than 5,000 ONTs. Some of those ONTs were, as you can see, illustrations there, deployed under the seats or in the seats in the stadium, and they're used for many services. So including security cameras, information panels, Wi-Fi, obviously there, multicast audio, but also for services, locating customers for food and beverage, and automating some of the services there. That was the first big project, but also there are other, let's say, big stadiums which we did, and some of them are illustrated on that slide. Then another, let's say, interesting example among our developments is in Egypt. So new administrative capital of Egypt, practically new city developed there, with Akud, which is a government company there. And it was interesting story because initially the project was designed as a point-to-point. So with a classical solution, let's say, there. And then it was converted into optical LAN because investors and decision-making people were impressed by the benefits of the passive optical LAN. And practically that was for our, let's say, a great win. So again, as in every, let's say, smart city, the number of services which are running there is massive. So practically everything what you could imagine, from the building management systems, security cameras, advertising panels, parking system, access control, energy management, everything. So it is a huge project. It's planned to host more than 6 million residential units there, I would say. So you could find a lot of information on the site there, but the project from our perspective is quite massive, which is including more than 100,000 ONTs. So within the different topology, but with the temperature hardened ONTs with a different number of ports with the power over Ethernet or POTS, indoor and outdoor versions. So we already shipped more than 10,000 ONTs for the first phase there. And last but not least, because our network of partners and the number of projects are measured in hundreds, and this is hospitality. So it is, let's say, to mention all of the services and lessons learned with such projects. We are practically working with all hotel chains that exist in the world, which you know and maybe you don't know. The services which are running there are, again, multiple, so including security, including video, telephony, back office services, but also access control, BMS services. When we talk about this, we talk about, fiber to the room, fiber to the beach, fiber to the tennis court. So all of the concepts and all of the names you can invent, it is implemented in such environment. The projects are from very small to very big. What we appreciate a lot is feedback of and specific solutions developed by our partners. You can see here some of the solutions which are implemented there. Some illustrations. We had also, our partners design specific towers for the camping facilities. So installations, indoor, outdoor, wherever you want, with the different form factors of the ONTs. So to conclude my part here, so what we are seeing as evolution in the optical LAN space. So definitely it is a transition from GPON to XGS-PON at this moment, but we believe also in the future evolutions versus let's say later PON technologies, mixing definitely of all of them on the single LANs. So that's one of the advantages of this. Infrastructure remains the same, while different generations of PON technologies could run over the same one. We already have a couple of projects, let's say few projects based on the XGS-PON. What is emerging as a requirement is also 100 gig and 400 gig services for multi-tenant and campus applications with the different optics, coherent optics and wavelength services. Service which is getting us also into the space of the low latency and transporting of the particular radio signals and the clocking are wireless services, so backhauling and fronthauling of the wireless services. And when we talk about this, we talk about Wi-Fi 6 or 6E, moving to Wi-Fi 7 with backhauling of 10 gig and similar. We have also, specifically in Asia, several deployments with the 5G cells, so access points, let's say backhauling within the building with mentioned timing requirements, and then last but not least, fixed wireless access there. Internet of Things is emerging everywhere, so it's all IP, it's always on with non-deterministic data requirements. And not to forget that security and high availability is having more and more importance in this world, and some of the enterprise features are let's say requested definitely for optical LAN. So like 802.1x, LLDP-MED, redundancy, chassis-based redundancy, encryption. Not only what you would be thinking maybe in the first place for military and government applications, but actually everywhere. So security is becoming one of the very important aspects here, a part of the green and other benefits which Martin mentioned as the growth potentials or drivers. That's all for me. Thanks for attention.
Good morning and good afternoon, wherever you might be. My name is John Hoover. I'm the marketing director here at Telabs, and I am a board director with APOLAN. I, along with Telabs, have been working with passive optical networks since 2003, when we first implemented PON with Verizon Fios implementation. And then I, along with Telabs, have been in the enterprise markets, all enterprise markets, since about 2008. When we introduced an enterprise passive optical LAN solution. Next slide, please. So some of the exciting growth that we saw in 2022 happened in these four verticals. So I thought I would spend my time speaking to these four verticals: government, manufacturing, office buildings, and transportation. So next slide. When we talk about government sector, we're talking about local, state, and federal governments. And when we talk about federal governments, we're talking about both civilian agencies and defense agencies. And Tellabs has installations within these organizations that are over 10 years old. They started out as GPON. Now they have added 10 gig symmetrical PON to these networks. And that was done in a very graceful manner without being disruptive to businesses. What it entailed was the cabling, the cable management, the splitters, the system management, the powering, all that stayed the same. It was done over the same single mode fiber. And what was added was a card at the OLT, the proper 10 gig optics, a combiner so that we could stack multiple wavelengths on the same fiber. And then they strategically placed the 10 gig ONTs out at the super users or the endpoints that had the bandwidth requirements. Those ONTs had multi-gig Ethernet ports on them, so you could pick and choose whether it was a 1 gig, 2.5 gig, 5 gig, or 10 gig connection down to those endpoints. I bring this up because it really speaks to optical LAN and its longevity and its resiliency. And that plays very well into sustainability. You know, we just saved a whole heck of a lot of plastics and copper from ending up in landfills, and that's important to do. Another thing it speaks to is the scalability. You know, we took those networks over the past 10 years from 1 gig to 10 gig with little disruption to the customer. The next thing that's really important, especially in the defense agencies, is security. And with a passive optical LAN, you are removing 10, 100, or even thousands of known security gaps in the network. And when I say known security gaps, I'm talking about IP addresses, I'm talking about control interfaces, the Ethernet switch management interfaces. Those all go away when you do it with a PON solution and you do it on ONTs, and actually you have less things to STIGs. That's a federal government term. It's things that have to be hardened and locked down. Like I said, it can be reduced from 1,000 or 100 or 10 down to 1 device. The other thing about the security implementations is that it's ideal for zero trust architecture. When we've known how passive optical LANs have less human touch. And once again, in a zero trust architecture, it's all about not trusting anybody. And so if you can do this from a centralized management, centralized intelligent, one door to lock, it's much more secure environment and ideal for a zero trust architecture. Next slide. Manufacturing. Manufacturing, I have been told, is the most difficult environments to work in. It has the most challenging networks. You have large cavernous spaces, high ceilings, long distances. You have chemicals, they're wet. They have temperature extremes. And passive optical LAN plays very well into these types of environments. On top of all of that, they operate 7/24. There's no time for network downtime, no maintenance windows. So in these environments, when you can push fiber deep into them, when you can get those splitters out there, you know, and the splitters are highly reliable, no maintenance devices, and then you put the small ONTs at strategic locations. What that allows you to do is you can reconfigure equipment lines, you can add new equipment in the line, you can grow the network, once again, without the normal disruption that happens if this was done over a legacy design. The result of all that is that, you know, it simplifies the network, it eliminates, you know, doing adds all the way back to a telecom closet somewhere. And, you know, that all saves CapEx and OpEx. One thing I always say is that if you have a switch 40 feet up in the air and you have IT staff that is working on a scissor lift, that's a bad thing. And that happens in manufacturing with legacy networks. On office buildings, what we're seeing here is an explosion of endpoints connected. The building automation systems, the building monitoring systems, all the smart building IoT end devices, you know, they're numbering in the hundreds and the thousands nowadays. So how do you connect those? Well, you can connect, you have better density and better reach in a smaller footprint with a passive optical LAN. And then post-COVID, you know, you already have the IT staffs are already stressed, stretched, and perhaps, you know, with labor shortage, it's hard to find the IT staff. So if you can automate the network, if you can do this with less human touch, that's a good thing. And passive optical LAN offers that with one screen to work from, centralized intelligence and management. Also, the sustainability, these corporations are working on their ESG, and a sustainability and healthy building certification is important to them. I know Gayla is going to go into this, and certainly Martin mentioned it, but an optical LAN can make tremendous contributions to sustainability efforts. I ask everyone to go on to APOLAN's website and look at a webinar on demand that we did in December that actually covered sustainability contributions to the from optical LAN. Last, we are very excited about powering innovations, and that comes from class 2, class 4, and microgrids. So from a class 2 powering standpoint, now we're connecting ONTs 2,000 feet out and then adding the PoE out another 300 feet. That's possible with class 2 remote powering. Now with class 4 fault managed power, we are truly unleashing the fiber-based LAN, and those ONTs can now go a mile out. So it really helps with flexibility design for these smart buildings. Next slide. Transportation is another very interesting market. And when I talk about transportation, we do have deployments in seaports, rail stations, railway networks, and airports. So in particular, I'm going to talk about airports right now. And these airports are mini cities. They have absolutely everything. They have digital audio. They have IP video in absolutely all forms, whether it be entertainment TV being played or whether it be kiosks. They have connections both indoors and outdoors. They have retail. They perhaps even have hotel. So you have just everything within these facilities. This particular airport has chose a passive optical network because of its high speed and future-proof. Well, what do they mean by that? Well, they're talking about the 10 gig symmetrical PON, and they're talking about the multi-gig Ethernet connectivity. And then they're talking about the ability to be able to go to 25 gig PON or 40 gig or even 100 gig in the future, once again, over that same single mode infrastructure. So it truly is future-proof network for them. They speak to energy efficiency. These types of airports could have a monthly electrical bill that hits 7 figures. So anything that you can do for them to lower their energy costs is well received and sustainable. We know that passive optical LAN utilizes less power, but it also allows you to exit telecommunication rooms. And when you exit a telecommunication room, you lower your air conditioning impact. But even better yet for airports is they can return that real estate footprint to revenue generating purposes. They can return it to retail, which earns money for the airport. So it's kind of a win-win situation for them. Last thing I want to mention is the PON protection out there at these airports. You know, there's redundancy at the port, the card, there's fiber route diversity, there's geographically located OLTs, and then there's PON link and PON path and PON health, where we're actually looking at the resources being used on the system itself and making switching decisions. What this means is that you can have two ticketing agents standing shoulder to shoulder, and let's say there is a catastrophic outage. That second, one of those ticketing agents is going to have a good connection. Their computer's going to be up and running, and they're not going to lose connectivity. And that's done with all the different PON protection, including the PON diversification. So that concludes my presentation, and I'll go ahead and turn it over to Gayla.
Thank you so much, John. So yeah, I'm Gayla Arundel, and I am the Market Development Director for In-Building Networks at Corning Optical Communications, and also currently the Chair of APOLAN. Corning has been in the industry, obviously in the fiber industry, for over 50 years, but we were one of the founding members also of APOLAN and are actively promoting Optical LAN with a fiber to the edge architecture in many different verticals. Specifically, mostly we are in North America and a few places in Europe. So today I'll show you a few of our case studies. So the first one I'll talk about is a manufacturing facility. You heard John talk about how difficult it is to operate within a manufacturing facility. So this one is DIRT. DIRT is a manufacturer of modular infrastructure, and they have a 200,000 square foot manufacturing facility with, it's really like Industry 4.0 type of completely automated factory. So with this, the challenge really was, where do you put your IDFs? They take up valuable real estate space, and they also hinder the planning of production and the flow of all this equipment. They wanted a network that was easily expandable, and also reliability counts. Every minute of their manufacturing in this highly automated space is very important, and you don't want any network downtime affecting any of your equipment. So in this particular case, we implemented our Corning software-defined LAN, which distributed the fiber to the edge and also used remote DC power, class 2 power, as John was just talking about, using a fiber and power composite cable. DIRT also has their own proprietary software design, and so we use pre-terminated harnesses, which is how they also incorporate some of these solutions within their own products. DIRT is also a member of APOLAN, and in this case, we also use partners like everybody else, and so we used Quipsys, who is also a member of APOLAN. So you'll see here that we use a lot less equipment. We were able to we're future ready. We also had much faster install times, especially with the pre-terminated harnesses and the less cabling. And all in all, this represented about a 30% upfront CapEx savings versus what would have been if we had done it with a traditional type of copper structured cabling architecture, with, of course, a lot less downtime and less cable and less space, which, as John also said, the sustainability numbers for fiber to the edge are actually quite astonishing. So the next example we'll talk about is actually, this is a school. This is a beautiful campus in North Carolina, the second campus of the North Carolina School of Science and Math. This was a very interesting one because there was a mix of historic buildings that have been there for over 100 years, as well as some brand new buildings on campus. This campus, there's about 300 living students, so there's also dorms involved, etc. And they really wanted to deliver the state-of-the-art technologies seamlessly across the campus, while also creating a safe and collaborative environment for students and for faculty. This is actually a high school that's part of the North Carolina university system. But of course, you have, you know, not the kids that are here are less, most of them are below 18 years old. So safety is a very big concern. Of course, some of the unique challenges here were in the historic buildings. We didn't have a lot of pathways and connectivity options. We also wanted to make sure there was security outdoors and blue phones everywhere, so that if there were any emergencies, they can, you know, immediately call. So outdoors was a big part of this campus. And of course, they wanted it to be future ready and yet affordable as well. So again, we implemented here the software-defined LAN with the same type of fiber to the edge remote DC architecture. And we really were able to streamline the whole architecture, reducing the space and really letting the architects, you know, be able to deploy within this mixed use of mixed environment of very old and brand new buildings. In this case, we also use one of our partners, Quipsys, who is also, as I said, a member of APOLAN. And then the third, last but not least, is probably one of the biggest deployments that we have done, and probably that you know, in the world today, of Optical LAN network. This is in the Resorts World Casino and Resort in Las Vegas Strip. It's 117,000 square foot casino, 3,500 rooms, each with 5+ connected devices per room. We also did backup house in this case, you know, 7 pools, that's over 2,000 security cameras, lots of food and beverage outlets. So you're talking a massive facility here. And they really wanted to make sure that they had a really connected experience for everybody, all the guests, all the staff, etc. So that was #1 priority in their case. So again, same type of solution here with the fiber to the edge, software-defined LAN, remote power. This was 22 million linear feet of single mode fiber. 24, we reduced the IDFs from what would have been 124 to 24 IDFs. I mean, that's a significant reduction in space required, etc. And we reduced what would have been 8 cables per room down to just 1 cable. So we were able to really deliver the fiber to the room, 10x longer distances, as I said, 80% fewer telecom rooms, and that 8-to-1 cabling reduction. These are some of the type of numbers that we see in a fiber to the edge optical LAN network in terms of, you know, less materials, less space, and that really and truly contributes significantly to the net carbon footprint reduction of an optical LAN network, both in terms of the embodied carbon, you know, a whole lot less materials, a whole lot less space, but also, as John referred to, on the operational side, with 80% fewer telecom rooms, you really and truly are reducing your HVAC load and all the other ancillary equipment that goes along with a telecom room operation. So this is where you get a big bang for the buck in terms of net carbon reduction over the lifetime of your building. So with that, those are the 3 case studies that I'll be talking about today. There are QR codes on the presentation if you want to learn more about any one of these case studies that are published on our website.
Thank you, Gela. So this brings us to the last section of this webinar, and that is on the Q&A. So if you still have questions, feel free. I know that we only have 5 minutes left, but if your question is not handled, then we can take it on later. So I got a question in on asking if this solution would work for electrical vehicle charging stations. Because as Sylvia is asking, most of these rely on SIM cards. So I would say absolutely. So but probably everyone will see that, because if you're a hammer, then everything looks like a nail. But let me illustrate my answer is that we did a kind of a pilot project in Belgium, turning these each light pole into a smart light pole, and so that light pole could do then electrical vehicle charging, was a Wi-Fi access point, and had a 5G antenna as well there. So again, there, if you if you restrict the use case to only electrical vehicle charging, where there is a minimal amount of data that you need to exchange with a central point, then I would say probably SIM cards are enough. But if you extend kind of the use case to higher bandwidth services, also thinking about the future that these electrical vehicles will have to do software updates and stuff like that, not only charging, then you come to the solutions where obviously you need a high bandwidth and high flexibility in the network ownership. And then also it's also the question on where do you deploy it. If you have electrical vehicle charging stations on private domain inside of the enterprise, inside of the airport and so on, indeed, then all these things come together. That's a bit my take. I don't know if any of the other panelists have anything to add to what I said.
That was good, Stefan. If it has IP Ethernet connection, we can backhaul it.
Indeed, yeah. So absolutely. So we did already do optical LAN use cases in the electrical vehicle environment. If that is all the comments from the panelists, just see if there is any other question.
Stefan, I wanted to make a comment or ask a question of myself. What are the benefits of fiber to the beach? I love that term, Slobodan. That was great. And there are benefits of fiber to the beach. I've always said this to our sales team and our customers and partners. I mean, these seaside resorts where it's highly corrosive, high salt, lots of lightning strikes. This is the perfect place to put fiber. Copper performs horribly at these seaside resorts. So absolutely, I'm a big fan of fiber to the beach.
I would also like to add, you know, we have a very interesting project of Marina where our, you know, where the fiber network is coming to all of the small towers where you connect the boats. Mm-hmm. And practically it is, you know, exposed to the sun, exposed to the salt, and it's working already for more than 8 years without practically failures. So if somebody thinks about this, this is really much better than anything else.
And here's another example. We're now seeing passive optical networks being used on shipboards. And what's interesting about that is sometimes when you speak to building owners and you say it takes up less space and it weighs less, it doesn't mean much to them. But if you go into a ship and you say it takes up less space and it weighs less, well, that means the ship has a higher draft and the ship utilizes less fuel. And then all of a sudden it just goes straight to the bottom line and it makes some money. So watch for passive optical networks being used on shipboard.
And unfortunately, passive optical LAN is not in the airplanes because they already use fiber.
Yeah, that would be a bit of a problem running the razor cable to that. But okay, all jokes to aside, but indeed, if you go into the different use cases, there's always kind of an advantage that optical LAN brings. Maybe next time we can do this webinar all together from the beach, and when there is a that would be awesome. What we try to show you is in this webinar, if I may conclude then, is that there obviously is the market report and the numbers that optical LAN is taking off, but with showing references and showing examples to you, you can understand why now the opportunity is there to and partners and customers are looking for an optical LAN solution for their use cases, because there are limitations of what copper can do, and so people are turning towards fiber for their different solutions. And for each of the segments, maybe there is a, let's say, an appealing or a competitive differentiator that an optical LAN network has towards the more traditional solutions. I would like to conclude here. So the information on our website is here. Feel free to give us feedback of the webinar and to check on our website. I thank you for your time, and I'm looking forward to discuss with you on a next webinar. Thank you.
Thank
Bye-bye.
you.
Thank
Thank you.
you.
Bye-bye.